Today we're talking about a chip tester, progress on the BitaxeTS chip tester, as well as an exciting new web-based DMM to monitor your power supply that you can use inside of OBS. Welcome back to the channel. I'm Brian, and here we try to fix S17 based amp miners. So I say try because as of late it seems like I just keep getting my butt handed to me. But today the soldering iron's turned off, the hot air station's sitting cold, because we're going to be talking about some projects that I've been working on for the past couple of weeks that will help the channel as well as help my repairs. The first thing we're going to talk about is the chip tester that you may have found on AliExpress. This chip tester ranges from $750 to $1,000 on AliExpress, and I contacted the sellers and none of them can give me any documentation or anything, but I managed to chase down who I believe is the real distributor of this tester, and they sent me documentation, as well as they allowed me to buy one at full price. So this little box right here, this is it. Comes with a socket, and it also comes with these special boards. There's three different colors. There's red, there's green, there's blue. And when I check the documentation, lovely documentation, it tells me that those are called switching boards, and the green one is for the BM1387, the blue one is for the BM1396, 1397, 1398AD, and then the red board, the red switching board, is for the BM1398BB. So that's 1, 2, 3, 4, 5 different chips that this tester will test. Now I will tell you that it does its best testing on the 1397, but it will test the other ones, so the documentation claims. I don't have any of those chips, so I haven't been able to test it. But you have the three boards that you can use. I'm not taking the blue one out because this is the one we're going to be working with. But if I needed to test a 1387, I'd use the green, and if I needed to test the 1398BB, I'd use the red. I'll put those to the side. They also generously give you this one circuit board that you can solder a chip to. I really don't think people are going to be soldering chips on and off, on and off. So that's why they built it to be compatible with the all-socket brand of chip socket. So this is similar to the one that we use in the BitaxeTS socket, but this one is a little bit wider and it has nice branding on it. Let me zoom in. There you go. You can see the nice branding. It's well labeled. It tells you what chips it actually fits right across there. They even give you a nice little, see, there's the all socket brand name and everything. And in case you were wondering, yes, I bought this kit from allsocket.com. Now, hopefully, shortly after this video is released, there will be a link to an AliExpress page by allsocket.com where you can buy this directly from them and know that you're getting the same thing I have here. But so far, they haven't given me the link. Before we turn it on, I want to get under the microscope, and we're just going to look at the construction because I want to show you kind of how this thing's put together. So what we have here is we have a power supply. I have not done any work on this board. I haven't done any cleanup on this board or anything. This is the way it came. Yes, that is ugly, ugly, ugly. So you can tell these boards are hand soldered, right? Have a nice bright display. If we look on the back side, you can see that it looks pretty good. I mean, it's not bad. It's definitely better than some of my work. But it's put together. You can see here where they kind of had to do a little bit of tweaking, right, on the solder. So I feel like there's certain spots where they hand soldered and fixed things and adjusted things. What I really like, though, is that they gave you these special extra tall riser pins so that they'll fit on the board. I would really just like to have a bunch of those extra ones for other projects. The all socket socket is nicer. It's instead of the cheap plastic, they've got this almost like rubbery feeling in there. It's actually spring loaded, so you don't press too much on the chip. Don't put too much pressure on it. That's really nice. It just feels better. It also costs a few dollars more. You just put it in like that. There's no key to make sure you don't plug it in the wrong way. The way you know how to plug it in, you look at the manual. All right. Power can, the documentation says this power can run from 7 volts, I think. Yes, 7 to 28 volts is what it says on page 2 of the documentation. So what I'm going to do is I'm going to go ahead and grab my power supply. I'm just going to get some little bitty pins here. Got my power supply at 12 volts. So that's fine. It sounds like a old Pac-Man game from the 80s. And this is really simple. Now that you see it doesn't pull a lot of power, it just sips power, right? Let me zoom back in so you can get a better picture of this. Right. So let me get a chip that is good, first of all. Here's a good chip. Now the way you put it into the socket is right there where that little dot is. That will be your pin 1. You seat it in there, and then you start by pressing the heat. Now there's 3 buttons here. This first button, and the documentation does a real good job of going over this. The first button changes the chip, and it's kind of neat because when you change to a different chip, it changes the color. So if you need the red board, it tells you red. Okay, this is a blue one. That's a green one. That's a blue one. So you don't have to go back to the documentation and go, oh man, which board do I need? Well, I'm back to the 1397, and so I'm on the blue board, right? That's the riser board underneath the socket. And so what I'm going to do is I'm going to press this one right here, the second button, and that's going to heat the chip up for just a second. Okay? It kind of runs through, and if there's a problem like this one, over temperature, so that's a bad chip. If it runs into over temperature, it's a bad chip. Let's find out for sure though, right? So I'm going to stop the test. The only way I found to stop it really is just to unplug it. So I'm going to stop it, and I'm going to set up. I'm going to take my chip out, and I'm going to flip over to this screen because what I want to do, and we'll talk about why I can now do this easier. All right, I'm going to dial my chip down. I want to see what does this thing do when I take it down to 1.37 volts. That's how we've tested them in the past. Great. Just plug in my probes. Now for this, I just use a set of test leads, right? And again, short them together. Okay, that's way too much current. Let's turn that thing down. I just want to see if it goes to 2 amps, I want to shut it down. I like that. A little bit more down. Okay, so 2 amps. So let's see what happens with this chip if I try it, right? Because it says that this chip is over temp. That's interesting. Let me ask you, would you accept this chip? Look at it. It just keeps going, right? Now, good chips don't do that. There we go. We've overloaded the chip. So, it's a bad chip. So you could find it by the good old test probe voltage and amperage, but this chip got tested out faster. Now, the funny part about this is that at one point this was a good chip because I've got a speed on it, but anyway, I'll play with that chip later. Here's another chip. Let's go ahead and flip back to, let me tune it back up. I'm gonna just turn my voltage back up to 7 or so. I wish I had a programmable. There we go. Okay. Put chip in it. Now this one I put an H on because this one failed. Let's zoom back in so you can see it. All right, I like the clear part there. Let's hit the heat tester. Okay, so it passed the heat test, so it warmed up. You can see the current, right? It tells you like it over that period of time, it got up to 1.819 amps. So it just kept getting hotter and hotter and hotter, or kept pulling more and more power. So now what I'm going to do is I'm going to run a test. Now if I just hit a test, it says it's okay, right? It gives me this. But what you can do with this is you can actually hold the test down up to 20 seconds. And if you hold it up to 20 seconds and it goes over 2 amps anywhere during that time, it'll error out. So this way you can find chips that I believe are weaker chips. Okay? Take that chip out, toss it to the side. Okay, so you're saying, Brian, why would I spend $750 to $1,000 for that chip? Okay, I got you. What about the chip that doesn't register a problem when you run the voltage amperage test? Let's try this one. Okay, past that. It only got up to 919 milliamps when it did that. So now I'm just going to press a test and I'm going to let it go. It's climbing. See, it's not getting as high. Oh, there we go. It passed. Cool. That's a good chip. Now the interesting thing about this, and this is why I think that when you have a failing chip, you might want to test it a second time. Previously, when I tested it, the CO failed, and it just reported that. We'll test this chip again later. What about frequency? What if there's a problem with a chip and its frequency? Well, we can do the same thing. I'm going to skip the heat test, and I'm going to go straight into the test. Oh, look at that. RSTO is bad. It errored out. Interesting. Now, what did I say a minute ago? I was like, hey, we probably ought to double check, make sure that it's seated well. Let's try it again. That time it felt frequency. So there's something wrong with this chip. Let's go back now and test and see if we could find this problem with the good old-fashioned voltage and amp test, right? I want to unhook, flip over to my meter so you can see, dial it down to 1.37. Okay, close enough. Get my voltage. Remember, put the negative probe on the big part of the chip. This one on this. Look at that. So, under normal circumstances, you'd go, man, this is a great chip. I'm going to use this chip, and you'd install it. And you'd fail. Because there's something wrong in the RST input-output or the frequency. So, this chip passes the normal test that everybody does whenever they're testing. Okay? Here's a fun one. I have no idea what this stands for. I marked an A on this one. Let's find out what A stands for. It's some kind of failure. All right. Since I'm using one power supply, let me dial it back up to at least 7 volts. Flip it back on. Cool. All right, let's run it through the test mode, shall we? Let's zoom in. Oh, wow. A, that's for amperage, because it immediately jumped up. So this one would also show up if we did a voltage test on it. Ever wondered about a chip that you're getting a temp sense reading problem and you're like, man, I don't know where it is, and you start swapping out chips? Well, here's an interesting one. This will also test the I2 or I2C. Look at that. It's stuck. On I2C, it's stuck. And then it shows you. It says error right there on the I2C. Now, I haven't played with the memo feature, but if you want to set a certain threshold, you can use the memo feature, which is this button, this middle button changes to the memo feature. You can use that and kind of pre-program a set level. And then you can run all of your tests to a certain level automatically instead of pressing and holding the test button down like I've been doing. I really haven't played with it. The instructions are kind of hard because they're not natively English instructions, but this works fine for me. It helps me to find the chips that have I2C problems and amperage problems and frequency problems and all kinds of different problems. Is it worth $750 to $1,000 from a vendor that may not actually accept returns because you don't know because they're on AliExpress? Well, that's up to you to decide. At $1,000, I don't know that I would pay for it. At $750, I don't know that it's a bad idea. I'm hoping that we'll get the BitaxeTS test socket version in quite a bit less than that when you get to assemble it yourself. But this is what the kit looks like. The beauty about this tester is that it will test, how many different chips did I say? 1, 2, 3, 4, 5 different chips. They figured it out. Now some of the testing, it tells you right down here, the chip is tested on the RST in and out, busy in and out, the C in and out, the R in and out, and the F in and out measurement of the core consumption current for the 1396 and 1397 chips. And the voltage of each of the 4 cores and the transit voltage of 0.8 and 1.8 volts. So you're able to get all of those tested on those 2 chips, the 1396 and the 1397. So if you don't want to wait, if you want to jump on this right now, you can contact allsocket.com. Go to their website, do the contact form, ask them that you want the you want the chip tester and the all socket for the BM1397 chip, and they'll work out a deal with you. Probably have to make a payment through PayPal. You can get it shipped to you in a couple of days, or you can wait a week or so and check back on this video. If you're watching it when I release it, check back and you can find a link down in the description. I'll change the link from allsocket.com. I'll change it to allsocket.com's AliExpress page, where you can purchase it through the normal purchase process that you're accustomed to if you buy a product off of AliExpress. Really neat product. I'm glad I bought it. I paid for this with my own money. They're not paying me to make this video, and I'm glad I did, because it's helping me to go through my chips. As you saw, it doesn't take any time. I'm not speeding up any of the test sequence for these chips. I want you to see just how fast it goes. Basically, you can test a chip a minute. Now, I will tell you this: when you're testing these chips, the bottom of the chip has to be cleaned off. The top doesn't matter so much because of the rubber, the sponge, and the spring. But the bottom of the chip has to be really cleaned off. Let me show you what the bottom of a chip needs to look like. So here we go. We have a chip that I have completely removed the solder from. I just basically, just like I normally clean up chips before I'm going to tin them. So this is what it looks like. You need to make sure that you don't have any solder on here, because if it's dirty and cruddy, then the inside of the socket won't work. And this will be the same way for the BitaxeTS test socket version. You got to have a clean chip, otherwise it won't work. Let me show you why I like this all socket brand. All right, so first of all, theirs comes with a nice little red dot, so you don't have to guess where pin 1 is. 2, look at the increased size of the pins for current, right? That is nice. Those are your current pins for the big heavy voltage, and then these are your signal pins. This is quite a bit better than this. As you can see, this version, the pins are smaller. Now these still are bigger pins than, or the power pins are still bigger pins than the signal pins, but they're not as big as the all socket pins. See, those, you can just look at those and know that you're going to get plenty of signal and power through them. So that's pretty cool. The socket tester also has heat sensing capabilities, so you don't have to get into overheat problem. So it will shut off like you saw when I was testing earlier. So overall, fantastic product. If you're in the market for a professionally or semi-pro assembled unit, this isn't a bad deal. All right, next up, just an update on the BitaxeTS test socket progress. So this is the second gen of the board. I changed the little tag there. I decided not to release this code, and I guess if you really wanted it, you could message me. But before you do that, let me show you why I didn't release this code. So we're still, what you'll get on the GitHub site is still the first version. Okay, this is I'm calling this the 2.2B version. And the idea behind it, let me show you this, is, see, the socket mounts straight to the board. Yes. Oh yeah, do you see this lovely modified heatsink piece? Yes. Yes. You no longer need your good buddy John to make one of these for you. Thank you, John, for your help. You don't need to hit up your friend to manufacture one of these, but instead you can get the AutoCAD file, or I should say the FreeCAD file, and you can actually get this manufactured through your favorite CNC factory to make these things. I personally recommend PCBWay, but that is a story for another day. But this is phase 2. Okay, why am I not releasing this? Well, because let me get under here. So these holes right here don't fit. They don't fit the Thanos mining version of the socket. So in order to make it fit, so I could at least test all the circuitry on it, I had to use my Dremel and cut out the hole. So I don't want you to have to do that if you get this for yourself. So I'm not releasing this. However, I do want to show you some other fun, cool things that are on this board. Right down here, you may recognize this. This right here is a pad for a USB-C connector, and on the back side right here is a nice little chip, so you won't have to use an external FTDI adapter. So you'll be able to plug this thing, the next version that'll be up for release, you'll be able to plug this thing straight in with your USB and use CGI miner or CG miner and start mining or running tests if you like to do that, as well as use the ESP32 miner if you want to use that way too. So both ways will be possible. So that's pretty exciting. I did move the fan over here, and for the next version I plan to widen it out and make this chip platform really more for what we need. As I learned from the other chip tester, I need to check those CO. I need to check the clock out. I need to check the RST out. I need to check the B out, the BO. So I need to check those values. So I'm working on that right now and redesigning the board for that. I'm also going to design the board with the proper holes. So it's up to you. If you want to buy the fancier, slightly more expensive all socket, you can buy that. So if you want to buy this now and then you want to play with the BitaxeTS socket version when it comes out, I'm going to make sure that the mounting holes for this are in the board, as well as the Thanos model of the socket. It's also going to be, I'm going to fix those holes so it lines up and fits properly. So both will be possible. The other thing is that this nice little heatsink adapter here that you use, it will fit on both the all socket brand and the Thanos brand of test sockets. So that's a benefit too. So a lot of progress there. Stay tuned for more BitaxeTS socket updates. So in some ways I want to say that I feel like I saved the best for last. This is a improvement to the channel, and I'm going to blame Scott from the BitaxeTS project for this one, because he inspired me to see what else I could do with the ESP32S3 chip. That thing is a great little microcontroller. What you see here on here, I'm gonna reach up. So this is my power supply. It's a 20 amp, 30 volt DC power supply. And you may notice, let's see, right over here, you see where I put the voltage and the amperage, right? Well, here's the thing. There's a camera involved, and it's in my line of sight. It's this big, ugly, honking thing. And see, I've got to really play with it to get it all right. Okay, so this is a USB camera, and with some recent updates to Windows 11, my OBS crashes more, and it complains about too many USB devices. So typically I don't use this bench cam that you're looking at right there because I'm using this camera instead. Well, let me show you what I changed here, and I'll show you how I get the amp and voltage back. Ta-da! It's back, right? You see it up there in the top corner. It's just sitting there blinking, but wait a minute, you can probably see it right here. It says 7.60, but yet what we see on the screen now says 5974994. That last digit will drive me crazy trying to tell it to you. Well, it's because I have built. It looks like I let the smoke out of the INA226 chip. Good thing I've got an extra one. Let me fix that. I'll be right back. Well, that was embarrassing. So in my zeal to get this all set up and show you this project, I hooked the power up backwards and burned up the chip. Oopsie! Now the only thing that actually burned up was the little INA226 chip from Texas Instruments. So what that tells me is I need to put a diode in here for reverse circuit protection. Okay, great, will do. So this is it. I plan to put this maybe into a project box and at the very least get it off of a breadboard. But comment down below, is this something that you would like? Would you like a something that actually works in a web browser? Let me show you what I'm talking about real quick. So in a browser right now, it's a very simple web page. It simply pulls up, it shows you amperage and voltage. This is the way I needed it to lay out. But you could change the code so that it would display it any which way you want. But those are the two values that it shows, and it does it through WebSockets. So it updates 3 times a second with very little load on the ESP32 or to your web browser. That's why it runs so well inside of OBS. This is what I've been working on. I'm really excited for it because it's going to help me clean up my desk a little bit. So I'll be able to see my power supply and you'll get better information in the video. And OBS will not crash as often. Those are all good things. If you would like to maybe build this project yourself, comment down below if it's of interest. We have a new channel sponsor coming on board and they will definitely help me get all the parts together to show you how to get the PC boards manufactured, even assembled if you want to do that, as well as getting a case 3D printed for it. That's a lot of stuff I covered today, and we didn't even fix a board today. So thanks so much for watching. If you like this kind of content, be sure to share it with others in the community. Check out one of these other videos. Give this video a like, and if you haven't done so already, please subscribe to the channel. Thanks again for watching, and I'll see you soon.